Yeah, yeah, that's right.
Okay, so yeah, so right here you have two files, two groups of files. I'm actually going to copy the GDF files. So the nomenclature is a bit strange sometimes. Yeah, sometimes you just think of something and then you just stick to it, even though it's not really the best. So in this case, there is one called 3NI hump, which means not vacuum treated, and TV means turbo vacuum, which means it's vacuum treated. That, yeah. So in this case, if I wanted to open them, so it's always a good idea just to have a look at the file. So in this case, I use this software called PowderPlot. So I'm just going to double click it. And I'm actually, by clicking multiple patterns, I can pick the one. And as you can see, it's very easy to use, the software. So it's also in the folder, this software called PowderPlot. And in this case, what you can see is that after the vacuum treatment, you dissolve any nitrites or whatever. And this sample is treated at 700 for, I think, 4 hours, something like that. So it's roughly the same as your long-term treatments at 650. And as you can see, looks good, right?
Yeah, yeah.
And yeah, and just to compare, I can also open one of yours. Which one should I open? Just with roughly the same content.
So if you open specimen number 2, that was 650 degrees, treated 16 hours.
Yeah, and do you also have the one that's vacuum treated of the same sample?
Yeah, the same sample. That would be number 3, which was vacuum treated for 8 hours at 650 degrees.
Okay, so as you can see here, now I overlaid everything, and yeah, so obviously your vacuum treatment is working just fine. You dissolve everything, and you only have alpha titanium left.
Yeah, that's number 3 is the one with the huge peaks.
Yes.
Yeah, yeah.
And let's, if we make it's always nice to make a comparison with untreated titanium, just so we have an idea.
That would be condition number 1.
The green one.
Ah, okay, yeah, you have it as well.
That's the green one now. Over in the corner, you can see them.
Yeah, yeah.
On the right corner. So what we see generally is that we, when we do our treatments in gas, we get a slight change in the texture. So this peak here, 002, it actually decreases slightly. And what we generally see is that, well, okay, this untreated titanium is also very high intensity, but the average ratio, so you have a slight texture change, but that's accounted for in the Rietveld software. But anyway, it's nice just to have a look at the data. Yeah, so these files here, they are all part of the files for the Rietveld refinement. So if I want to open those, I just open WinPoww, open project, and then I pick this vacuum annealed. And in this case, this is the refinement for the file. And one clever thing we could do is that we can actually just save this project here as, so that's M3. So that's your vacuum treated sample number 3.
Okay.
So now it just keeps all the files, and then I just go into edit project files and then GDF, and then I pick number 3, and then I press compare, and this is the fit, the old fit, together with your data. And as you can see, it's not completely far off the peak positions and so on. Of course, the intensities are wrong, but that doesn't really matter. And so how do you refine something? Well, you have this thing called the control panel, and in this case, you should just keep the control that I set it to. So just save new projects. In this way, you don't have to think about this, but generally we use this Guinea tangent angle of 45 degrees. That's because you angle your foil 45 degrees and then you rotate it. So, and a Guinea means transmission.
Yeah, it's this arrangement we're using there for trans.
Yeah, and also you only have alpha 1. That's why I put alpha 1 and alpha 2 at the same value.
Okay.
So you only have alpha 1. I also do number of cycles, and in this I fit from 25 to 80 because you don't need the whole range. And whatever is before 25 is not relevant often. Maybe you have a rutile sometimes, so you can have a look at that. But if you want to change the area, you can just change this number here. And I would generally say that it's a good idea. So this diagonal dampening factor, when it's at 1, you don't. It's inactive. And the diagonal damping factor is a way of preventing the software from running amok. So let's say that you start refining and then suddenly it wants to change everything at the same time and then it crashes. So when you start refining, you could just set this to 1.05 or maybe 1.08, something like that, and then slowly lower it.
Okay.
But in this case, it's a very, very simple system, so you should be able to do it without it. But I think it's a good idea just for you to use it generally, and then just press refine a lot of times. And when it looks good, you can lower it to 1 and then refine one more time. Okay. So initially, okay, that's a bit much. So this is the background. And we're just going to do 5 background values. And generally, so let's say in this case, if we want to push the red line up a bit, that's the background line. Then, as you can see, the background should be a bit higher.
Yeah.
And the line on the lower part here, that's the difference curve, and you can actually change the colors if you want. So let's say that you want a difference curve color, say orange, to visualize, well, what am I actually lacking? And in this case, you can see there is a slight difference in intensity for the background. So to refine something for the background, you need to click here. In this case, I use the 0 shift, but I actually think we should just remove that and just set that to 0, because yeah. So now I'm actually showing you how to refine, because what the heck. Okay, so this is the phase. This is the alpha phase, and to load in a new phase, you just press add phase, zip file, and then whatever you want. So let's say that you think you have oxides, you just press here, press OK, and then TiO2, and then press compare. And then it's only green lines. That's a bit confusing. So if you go into plot options, phase 1, phase 2, then you can see different colors. And in this case, it's quite clear that you don't have rutile. So it doesn't make sense to put that in. So we're going to remove it and then compare again. Okay. And when you only have one phase, you can only show some for some reason. So you need to put it back. So when you want to refine something, you need to have a 1. And in general here, the scale factor is the intensity of the peak. The unit cell is the position of the peak, so you have A and C. And you have full width, half maximum, that's the width of the peak, the shape. And peak shape is also something that should be refined also. And the
Okay.
preferred orientation, that's the texture. And that's it, actually. So it's not more complicated than that. So you have intensity, position, and shape.
Mm-hmm.
And perhaps you could write. So could you write something down on your
Yeah.
computer, just the rough values? So you want in the full width half maximum, just write W should be between 0.02 and to maybe to 0.8, and it can also be negative a bit, so maybe minus 0.1. So what my point is that you don't want extremely high values of W, V, and U because they're interconnected. So sometimes if you just it runs amok, it will just start raising the W and lowering the V, and then you can see a description of how it fits the full width half maximum in the compendium.
Mm-hmm.
So it's just a peak shape thing, and the V should also be reasonable. So these values that you see here are reasonable.
Okay. Okay.
And,
So a reasonable value for V would also be in the same range somewhat, or is it?
yeah, something like that. You don't want
Okay.
10 here. Whenever you get like 5, 3 or whatever, or -5 or something, then just reset it. Just press 0, 0, 0, and then the default value for W is actually 0.02. That's the
Okay.
default. So you don't actually also need the U often. That's only when you have very intense peaks at very high to theta. So at low, again, it's described in the compendium. It's this one. So as you can see, the V and the U depends on theta, while W doesn't depend on theta.
Mm-hmm.
Yeah. And then there's another very important thing. You only refine gamma 1, because if you refine gamma 2 and this, then you get two things that depends on each other, and then the software crashes.
Okay. For understanding gamma is what?
That's the peak shape. This one, G1.
Okay.
So I don't never refine G2 or G3. Yeah.
Okay.
So this here is the texture. So in this case, I know that this peak here is the 0, 1, 2 peak, and it's relatively intense compared to the value right now. And for the texture, when the value is below 1, you increase the intensity, and when it's above 1, you decrease it. So in this case, this is a bit high. So I think the values should be between 0.6 and 1.4. Don't go 10 or whatever. 0.6 and 1.4. That's good enough value. So I think this is actually a bit too high also. Yeah. So I'm just going to reset it, which means that I just set it to 1. So remove the texture, and then I press 0. So whenever I do 0, and also the default value for G1 is 0.5. Yes. So I'm just gonna default everything now. So 0, 0, 0, 0, 0.02, and then 0. Let's look how the shape changes. So now the shape, our peaks are actually quite narrow.
Mm-hmm.
Yeah. And this peak position. So what I prefer to do is that I actually manually position the peak. So right now, I want this peak here which is positioned as 40.2. I want it positioned at in the left corner here. You can see the values. So this is 40.2. I want it there. Right now it's at it's at 40.2. I want it at 40.12, which means that I need to change the C and the A slightly. So if I just say 4.7 here, then how much does it change? Well, now it changed a bit. And then I need to change it a bit more.
Where did you just change 4 point?
That's the C lattice parameter. So now I just made a guess. I just said, okay, let's just say 4.75. Now it actually now it looks okay. And you don't have to do this. And in this case, I actually changed too much because I picked the wrong peak. So in general, this 0.1 peak that depends on A, and this peak depends on C. So I changed the C lattice parameter too much. So I'm going to lower this again to like that, and just look at the C peak.
How can you actually pick the peaks? You just zoom in and then it will automatically pick that one, or? Well,
in the left corner, you can also see the peak position and then 002.
Yeah.
And that 002 means that it only depends on the C lattice parameter.
Yeah.
That's just the way it is. And this one is 0.010. I think in Topaz it's 100, but whatever. So that's for the A lattice parameter, and then I just change this slightly. So I just say 2.95, whatever. I just made a guess. I want to change it slightly. This looks fine. It's roughly the same position. You don't actually have to do this. You can also tell the software to do it. This overall temp, that's just another way to do intensity. But so that's the last thing you refine. I'm just going to put it at 0 now. And then let's have a look. Okay, so I only want to refine. So I'm just going to set everything to 0. In this case, 0 is your friend, and then I'm going to refine. And when you press Control U, you can refine again. So in this case, it actually fixed the background. It looks okay. And it changed the intensity somewhat, but it's still not great. So then I just put one here and then one here, and then refine again. And we can refine again. And in this case, it's clear that you have a lot of texture. So instead of trying to refine everything else, you should just say, okay, this peak here is way too intense. So I need it lowered. So I just say 002 and then 1 here. And then it lowers that one. As you can see here, it's above 1. But I need a bit more intensity, maybe for, I don't know, this one or whatever. But I think right now it's the peak shape. So I'm just refining that a bit more. And then in this case, because it's a rather simple system, I can just, I'm doing diagonal dampening 1, but you could do a bit higher. And then save the project and then back up the project. Do that every once in a while, because if you do a mistake, let's say that you put in 5 here, and then I keep that just to show you how wrong it can go. Yeah, and then it crashes. So if I want to restore it, so now I completely ruined the fit. And as you can see in the values, it doesn't make sense. So if I want to restore it, I just press restore backup project and then I go into compare. And as you can see, it's back. So in that way, whenever let's say that you have 3 phases and they overlap, then it's a bit more complicated. So in this case, I can also refine this overall temp. Don't use this asymmetry correction. Never use that. And a bit more texture, we could just do 0, 1, 0, whatever. And see. And then down here you have this chi2. So you get this log file out. And the lower the numbers for the chi2 and also this RP, the better. So the more you get closer to 1, the better. But actually the best thing you could do is just to visually look at the fit. The lower the difference curve, the better. So in this case, you have a slight asymmetry, and that's expected. And I wouldn't start using the asymmetry correction for that. And also a lack of intensity for this peak here, that's completely normal. So maybe we could change that texture to that one. Does that help a bit? No, not really. I'm just pressing Control U. And I think that's roughly the best you can do. And the good thing here is that you can clearly see that something is missing. So with this difference curve, you can actually see that you have a tiny peak at roughly 36.3 and 39.2. And that's pretty much it. So this indicates that you have a simple cubic something. And I think that could, well, if you think about it, you treated it with nitrogen. And so that could be either TIN or TI2N. So yeah. I'm going to make a guess that it's TI2N. Because, yeah. And does that make sense? Yes. So
that does make a lot of sense.
Like that. And then you could actually, if you want, you can remove the face that you're already done with. So you only show the new face. And in this case, TI2N, the most intense peak is this one. And that pretty much fits. So what you want to do is that we want to move this peak over here. And similarly, this peak over here. And again, how do we do that? We just go into the phase 2 and then we just move it. And because we want to move it to the right, we just lower this. We just make a guess. I don't know. And then we look. How does it fit? It looks okay. That was a bit too much. Yeah. So in general, you don't actually have to fit this peak, because in theory you could, but the problem is that you have a lot of lack of peaks and so on. So it's so tiny that I wouldn't start bothering to fit this. But in theory, if you did, you could use this quantitative analysis. So let's assume that you made a perfect fit. Then you can actually say something about how much of each phase you have.
Yeah.
And I did something similar in, let's say, like this. So in this case, I have a lot of carbides and alpha and so on. So the orange one is alpha. And in this case, I just tried to do the best I could. And here you have 3 phases very close to each other. And then based on that, you could go into the output file and then quantitative analysis. So in this case, I know that I have 7.3 weight % of alpha and a lot of carbide. It's because it's treated at 1100 degrees in CO. So that makes sense.
Yeah.
One very important thing is that you need to have the same value here. So 11 for all of them and the same value here. So in phase 1 and phase 2, you have 11, the same value, and so on. And generally, if you want to do quantitative analysis, don't use texture values. So even the, okay, yeah, only for one phase, general. Yeah, okay, you can actually use texture, but just remember this one, 11 and so on.
Yeah, I don't think that I would change the texture too much in general. I don't know, it's also some kind of interesting.
Yeah, but well, you have the foil has some textures already.
Yeah, for sure.
So anyway, based on this fit, I can tell you that you have a lattice parameter of this and this, and based on that, you could calculate the CA ratio, and then you can figure out how much nitrogen you have in it based on actually data I made.
Could I actually, I have an idea of residual stress. I've only looked into phase analysis so far with the XRD pattern, but I thought there would also be, it would be possible to have some residual stress analysis.
Well, when you do the vacuum treatment, you should have stress relaxation, but of course, that's just theoretical. You will have some stress, but in general, your peaks are quite narrow, which means you have large grains. And also, if you look in the light optical microscopy, you have large grains.
Yeah.
And I wouldn't say that you could do a meaningful Williamson-Hall plot on this one and so on. Like, I think to do stress analysis, you need to do a specific measurement. You can't do it based on this, so don't bother.
Okay.
What you can get out is quite precise phase analysis and also that is parameter. So yeah, I don't know how meaningful this was for you, but anyway, that's it. And if I wanted to do it on the other one, so that's M2. Now I'm just saving this project and then picking the 2 file and then having a look. And in this case, it's a bit more complicated, but we can make a guess that we have TIN, Ti2N, maybe hydride. So we can just start putting them in and see what happens. So this is TIN. And so the TIN peak, that's the last one, that's phase 3. So this is, if you have a TIN that's nearly completely filled with nitrogen, you should have a peak position that's roughly here. And I don't think you have a lot of TIN. Like if I lower it, and so I actually don't think you have TIN.
Wow, that's interesting because it appears golden actually.
Yeah, well, then the TIN layer is extremely thin. Like, is it does it look like bronze, or does it look like gold?
For this sample, it was you have loaded number 2 right now, right?
Yeah. Then I'm gonna try and load in the hydride.
It is bronze.
Yeah. Then it's a very, very thin layer of nitride, and that layer is so thin that it's actually close to the baseline. So it is there.
Okay.
And,
but there's more noise than an actual signal.
Yeah.
I mean, there is no noise.
I think in your case you have you actually have a lot of hydride, which is, wow, that's a lot of hydride. So okay, let's have a look. Let's assume that you have Ti2N, and the most intense Ti2N peak, that's this one. So that fits. You have Ti2N. And then this is the alpha peak. You have a large concentration gradient in alpha. That also makes sense because you didn't vacuum treat it. So it's very wide. So you can actually fit it as multiple alpha phases. And then you have and this is also a very wide alpha phase because, again, concentration gradient. And the same thing here, but you also have some overlap with this brown dotted thing, and that's the hydride. And there's only one hydride peak that's not overlapping with alpha. Also here, overlapping with alpha, and that's this one. And that's why I know that you have a lot of hydrides, which is surprising. So yeah.
Okay,
so
the one at around
the pink one, that's Ti2N. So let's just ignore that one. But this is a clear hydride peak.
Okay.
Yeah, and we can easily refine this. We can fit the concentration gradient just by using very wide peaks. So let's assume that we want to try this. I'm gonna lower the intensity of the hydride just to remove it momentarily, and then I'm gonna save it back up, and just to see, can I actually do this? And if I do 1.1 here, then it will go very slowly. So let's see. Let's try again. So you can also tell the software to try and do it by itself, but it can't really do it.
Okay, this is this refine function.
Yeah. So in this case, it completely bungles the. So this is only supposed to be 0.3 to 0.7. So let's keep that at. Well, we know they're quite wide, so just 0 here, and then remove the texture. Oh, no, 1, 0, and this 0, and then let's just remove all this, and then because we know it's quite wide, we're just gonna 0.2, and then when you look at the peak, now they're better, and then we're gonna try and refine again, and so what I'm doing here is actually I'm doing something that I could do just as easily by hand. I'm just showing you that it is possible to try and force the program to do it.
Okay.
Right now,
so right now you were
well,
just putting all the default settings back, basically.
Yeah, exactly. And then I know that because these values are very high, it means that something is not being fitted, and that's most likely this hydride. Let's have a look. Yeah. So I'm just gonna. So if you don't want to refine something, you just press 0 here. So right now we're not completely happy, but we don't hate our alpha fit, and then we're just gonna fit our hydride by itself. There we are, and then it placed it in the middle, so that's fine. And then again, you don't actually have to do this. And right now I'm just throwing around values because I know that the diagonal damping factor is very high. And the background starts looking a bit strange, and yeah. So anyway, if I like the background as it is, I can just also click here the black one. But anyway, this is just to show you how you could do it. But in this case, I know that the hydride is wrong. This is way too high, so I'm just gonna something like that. And then yeah, also the intensity is way too low. And I know that I'm working very quickly, but you're not supposed to do this, because the good thing about the software right now for you is not to refine this, because you won't get anything out of it. Yeah. Well, in theory, you could use it to say I have this much hydride if you do the quantitative analysis. Like you could get some meaningful results potentially out of this, but I would be skeptical.
Yeah, I have my doubts because, as you said, there were a lot of overlapping between hydrides and alpha titanium. So I don't think that you can really get a qualitative.
Well, but the good thing is that you have this peak here for the hydride by itself. So it is possible. You could try, but like doing this for me would take, I don't know, half an hour, and it's a good exercise. But anyway, the good thing for you here is just to show that you have hydride, you have a bit of Ti2, and perhaps you have a tiny amount of Ti, and then you have expanded alpha.
Yeah.
You remove the hydride. So this peak here, that's the main peak. And did we make a?
No, I think this is actually what I want to get out of these measurements, that I can clearly say which phases are available, and that I can,
So now I did a restore project, as you can see. So now we're back with a good background. So before, if I wanted to do this, I would actually lock my background in. then it doesn't touch the background.
Okay, and lock the background in, you're doing by?
Just clicking here. So now it's refining it. Now it's not refining it.
Okay, okay.
So now it's locked in.
Mm-hmm.
So if I wanted to fix this hydride, just to show you how it could be done, then something like this. But anyway, you have a lot of overlap, so it will also affect the. But yeah, maybe something like this. Yeah, but anyway, then your once your peaks start doing like this, like getting all jacket,
Mm-hmm.
like this one here, that means that the full width half maximum is wrong. So this is completely bungled, and also this G1 is. So yeah, I'm going to restore it, and that's it. Okay, and then compare. So now you're back to square one. So in this case, I wouldn't actually use it as a refining tool. I would just use it as a way of like just removing peaks. So you know that this peak is alpha. You know there is an overlap here between the hydride and alpha, but you also know that this peak is also hydride and it's not overlapping. And
yeah, so I can clearly state that there are hydrides.
Yeah, exactly. And also that you have Ti2N.
Yeah, that is actually perhaps everything I need. That's
yes. So yeah, and if you want to open it, you just go here, open project, and then M2. And sometimes when it says that, oh, you can't load the file, just go into files and then reload it.
Mm-hmm.
There we are. Okay, and you can also just see how does the rest look like. Like I can load number 5.
Mm-hmm.
Sometimes
5 is
or I can
treated for 16 hours at 600 degrees, so even a lower temperature.
Yeah. Maybe number 8.
Number 8 would be interesting. Yeah, the double amount of time.
Because then you should have some hydride, or some. There you could have some nitride. I mean,
titanium nitride. Yeah, that was really golden.
Yes, that makes sense. So now I'm just gonna try and visualize the. So this one here is still. We can. It's actually 4.4, roughly. Yeah. And then I'm actually gonna save this project as M8, and that's how easy it is. So it's not that difficult. Now you have a new project, and yeah,
that's good.
I can also back up this one and so on. So, and the settings are the same for all of them. So, and in this case, I can easily tell you that, well, you have more nitride Ti2 and you have a bit more hydrides, and because the hydrides overlap, as you can see, the hydride, that's the brown one. It actually overlaps quite a bit, but you have a huge concentration gradient, which you can look at this one, which is unaffected by the hydride. So in this case, you should actually fit 2 distinct alpha phases. So in this case, I would actually load in a new alpha, and yeah, alpha 2, and then with a lower whatever, something like that.
Yeah, different lattice.
And then you will get a new peak. So this one should be roughly over here, the green one should be over here, and the orange one should be here. So orange here, green roughly here.
Yeah.
Just to show you that you have a concentration gradient. And do you have any nitrides? I don't know, maybe.
Probably.
And so to remove, now it looks completely convoluted, but if I just remove all of them, so, and the nitride lattice parameter, that what governs the position, but this shouldn't change that much.
Yeah, nitrides are not, they should be stable.
Yeah, I think it's safe to say that you might have a bit of nitride. I think you have a tiny layer of nitride because that will form.
But that's interesting. I thought there would be a major peak at titanium nitride, but apparently not.
I think it's quite thin, and Thomas will also tell you that you have this interference coloring. So yeah. Okay. So I'm gonna send this back to you, and actually, could you share the video with me? Just if I want to do an introduction for Rietveld, I can just send them to them, and they can be confused a while.
Yeah. Thank you a lot. I will stop recording and I will send it to you.